Hello and welcome to Who Knows More of Math. Today we will be evaluating derivatives. We will be evaluating the first derivative test, the second derivative test. We will be evaluating the maximum and minimum points. We will be finding out our concavities, and let's see how it turns out. So what we're going to do today is we're going to derivate. The first derivative test allows us to know if the graph is going to be increasing or decreasing. It gives us the maximum and minimum points. And it also allows us to know if the graph is going upwards or downwards. Then the second derivative test allows us to know the concavity. The concavity is the openness of a graph. It can be either upwards or downwards. And in one corner we have Alejandra Orozco, and in the other, Michelle Marin. Come here, players. This is the derivative they have to derivate. F of x equals x over x squared minus 1. So you know that our domain is x belongs to all real numbers except for minus 1 and 1. We got them from our restriction here in the denominator. So we got the x-intercept that we just equal to 0 our function. We pass this multiplying. So we have x equals to 0, point A, 0, 0. And then our y-intercept. We substitute the value of x for 0. So we have 0 over 0 squared minus 1 equals 0 minus 1. 0 over minus 1. So y equals to 0. Our point B, 0 to 0. And then our symmetry. We just did our function as f of minus x equals minus x over minus x squared minus 1. And it has no symmetry. And then we go to our horizontal asymptote. We evaluate the limits with infinite. We have infinite over infinite to the square. It equals to 0, and here is just the same. And we have that our horizontal asymptote is at y equals 0. Our vertical asymptote. We have two restrictions, and we're going to evaluate them both. So we have that the limit of x approaches minus 1. We replace it in our equation. We have minus 1 over minus 1 to the square minus 1. It gives us number over 0. So we have to evaluate with the right and left side. So we have that the limit of x approaches minus 1 from the left is this, and it gives us minus over plus. So we have minus infinity. And then we do the same but with the right side, and it gives us minus sign over minus sign. So we have a positive infinity. And then we do it with our other restriction that is 1. We again replace values, and at the moment that we replace it, it gives us number over 0 because 1 to the square 1 minus 1 is 0. And then we do the same from the left, from the right. We replace our values. In here, with 1 from the left, it gives us positive over negative, so we have a negative infinity. And then here with 1, we have positive over positive, so we have a positive infinity. And we know that our vertical asymptote is at x equals minus 1 and 1. So we have our function y equals x over x squared minus 1. And we did a quotient rule in here. We multiplied, remember it's a negative sign in here. And then we got that our first derivative is y prime equals minus x squared minus 1 over x squared minus 1 squared. And then to our second derivative. So we just have to derivate our derivative. So again we did our quotient rule, remember the minus affects, and then we have that our second derivative equals 2x to the cube plus 6x over x squared minus 1 to the cube.
So this is our graph for this function, its first derivative and its second derivative. And we have a vertical asymptote in minus 1 and 1, and a horizontal asymptote in 0, and our point B and point A is 0, 0. For the first derivative of our last function, that is this one, we have this graph, and the horizontal asymptote is in 0. It has a negative concavity, and this goes downwards to infinity. This is our graph for the second derivative, and there's an horizontal asymptote in 0, and two vertical asymptotes in minus 1 and 1.
You once said I was an awkward kisser.
She may contain the urge to run away, but hold her down with soggy clothes and breeze blows. Cetirizine, your fever, scream me again. Never kisses, or do you ever send a full stop? Do you know where the wild things go? They go along to take your honey. Way down how we build our breakfast down and say my love, love, love. La la la, muscle to muscle, to toe to toe. The fear has gripped me, but here I go. My heart sings as I jump up. Your eye grips and as my heart is shutting up. Do you know where the wild things go? They go on to take your honey. Bring down our sleep, build our breakfast, now let's eat my love, love, love. She bruises calls, she splutters pistol shots. Hold her down with soggy clothes and breeze blows. She's morphine, queen of my vaccine, my love, love, love. La la la, muscle to muscle and toe to toe.
Derivatives are used in real life to know the velocity or the acceleration of an object, or to see how your business has been performing over months. Also to know if you need more or less of a product for your business or in finances.